Chemically happy. The chemistry behind fluoxetine. What is fluoxetine? Fluoxetine is a selective serotonin reuptake inhibitor. Your serotonin reuptake inhibitors intake serotonin from your brain. So this drug controls how much serotonin they are able to intake from your brain. The drug is a antidepressant and is commonly used to treat depression, panic disorders, mood disorders, OCD, and is commonly known under the brands of Prozac, Alina, and Prozac. SSRIs actually replace older group of antidepressants called tricyclics because they had fewer enantiomers in them, which meant that they had fewer side effects because they didn't have these similar structures that had different effects. Serotonin. Serotonin is a type of monoamine and neurotransmitter responsible for mood regulation, sleep, and appetite. Imbalances in serotonin levels are linked to depression and anxiety. So when those serotonin intakers take too much serotonin in and do not allow the serotonin to fully flow along its path and reach all the different parts of the brain, you can have wrong concentrations of serotonin in your brain, which can cause these levels of depression and anxiety. Fluoxetine blocks the serotonin reuptake transporters, the SERTs, decreasing the serotonin availability in synaptic spaces and improving your mood regulations. Older drugs like those tricyclics had broader effects and more side effects, again, due to those enantiomers. And our fluoxetine is more selective, leading to fewer adverse reactions because goes through a more synthesized process, removing those enantiomers. Fluoxetine. So here you can see it has the structure as well as our molecular formula, and then we also have our hydrogen bond donor count of how many hydrogen bonds it can donate, its hydrogen bond acceptor count, its rotatable bond count, its heavy atom count, which has quite a few heavy atoms, as you might be able to tell there. Covalent bond count, and then our isotope atoms count, and then all of that information came from PubChem. Uh, some key properties about fluoxetine is its lipidity, which allows it to cross the blood-brain barrier, which allows it going through our brain to be able to um, transport easier and with that serotonin and everything. And then also it has strong plasma bonding, um, which enhances its efficiency as a drug overall. Synthesis process. So the synthesis process of fluoxetine is a very complex process. It's actually a very complex drug to make. It goes through multiple reactions with multiple different products, reactions, different stages, different chemicals until it is purified and synthesized down to that fluoxetine that we have on our FDA market. Also, of course, it gets quality control and then other FDA controls as well. We also have it has a chiral center, and the S enantiomer is more active. And as I was talking about those enantiomers again, they contribute, they remove the unwanted ones so that we don't have those negative side effects that we don't want with our drug. Our fluoxetine synthesis process is um, has a lot of processes, and then one of that key reactions is the manic reaction, which is a three-step condensation reaction. Kinetics absorbed in the gastrointestinal tract and metabolized by the liver. Um, it has a very strong half-life, which is very good for single dosing for once a day. You kind of want something that even if you miss your dose, you're going to be able to still have a level of the drug in there. It's not going to deteriorate insanely in our stomach acid and be gone. Also, the active metabolite norfloxacin prolongs its effect as well. This all helps with fluoxetine's efficiency as a medicine in the antidepressants. Something in mental health is a medication you really don't want to be off of, and you want to keep those people in a balanced state of brain chemistry. So effects on the brain. So fluoxetine actually downregulates overactive serotonin receptors, which is those SERTs that overreact and are taking up too much of our serotonin out of our passageway. Like I said, not getting our serotonin throughout our brain and that equal concentration that's needed for a balanced brain chemistry. And then we also have increases in brain-derived neurotrophic factors, and then that promotes neuroplasticity within the brain. And then we also do have some other. Is it altering your genes? It alters your brain chemistry through that pathological neural links. So it's going to alter your mood and as well as your metabolism and different things as a side effect of that as well. Here's my works cited for all of my information. Most of the images and information was sourced from PubChem. Some of it was sourced from some of these other sources here, and then some of the images have their own source from public domain as they were inserted.